that your first mid examinations are from 1st, 28th.
Yes.
Pretty lousily joining. I think we need to change the pair. I need to. Who are like Varun? Please mute your mic. My God, today ECU2 kids are on a virulent 103 Siddharth. Come on, please call him. Okay.
అదే నీకు నేను రోజు మంచం పైన పడుకుంటాను కింద కూర్చుని అవుతాను స్కూల్
Hello. Is the CR of the class?
Madam, you can mute his.
Ma'am, you can mute him if you are the host.
Huh?
You can mute him, ma'am.
I can mute him. How?
Yes, ma'am. Just click on the mic button.
Okay, I can mute him. Okay. My God. Good. Thank you. Okay. Then in the last class we have studied about the construction of electrochemical cells and the types of the electrodes. Okay. And I hope by this time you're a little more confident on writing the Nost equation and its application at the electrodes which are under non-standard conditions. అర్థమైంటుంది కదా Nost equation రాయడము దాని అప్లికేషన్ నాన్ స్టాండర్డ్ ఎలక్ట్రోడ్స్ దగ్గర సరే accordingly we have come to that point of discussion of the electrodes which are being used for the reference purposes or for umpteen applications. Now what it means by an electrode? Roll number 60. 1. Roll number 60.
Yes, ma'am.
Good morning.
Good morning.
Now what it means by an electrode?
Electrode.
Electrode ఎలా బిల్డ్
I
చేస్తారు?
forgot, ma'am.
అజయ్ ఎలా కన్స్ట్రక్ట్
I
చేస్తారు
don't
ఎలక్ట్రోడ్?
remember,
సుందర్
ma'am.
చెప్పాలి నాన్న.
I'm unable to recollect, ma'am.
ఏమిటి ఒకసారి don't just sing me one song. Sing me one
Which song, ma'am?
Any song of your choice.
Any
Not
song?
recent one. Not recent one. Sometimes films which have got released some 5 or 6 years back when you were in school. Huh? Oh, okay.
Okay, ma'am.
ఏంటే
I
ఏదన్నా
can't
తొందరగా
sing,
చెయ్యి.
ma'am.
ఏంటి ఎప్పుడో నువ్వు స్కూల్లో
I can't.
ఉన్నప్పుడు ఎప్పుడన్నా నేర్చుకున్న పాట పాడు.
Okay, ma'am. పలుకే బంగారమాయేనా అందాల రామ పలుకే బంగారమాయ. That
ఏ
one.
సినిమా?
Uh,
ఏ సినిమా?
రామదాసు, ma'am. రామదాసు.
ఓకే. ఎలా గుర్తుంది?
Yesterday only I saw, ma'am.
సో ప్రాబ్లం నీ మెమరీతో కాదనమాట. ప్రాబ్లం దేంతో? నీ ఇంట్రెస్ట్ తో. సరేనా? ఓకే, గుడ్.
I got it, ma'am. Up to next equation, I was clear,
నేను
ma'am.
అడిగిన సింపుల్ క్వశ్చన్ ఏంటంటే, ఇది అందరికి, ఇట్స్ నాట్ అలోన్ ఫర్ అజయ్, ఇట్స్ ఆల్ ఫర్ ఎవ్రీవన్.
Electrode means
It is constructed taking a metal rod dipped in its own metal ion solution. It's also called as half cell, and the reactions taking place are called as half cell reactions. So whenever, how many types of electrodes? Two types of electrodes, anodes and cathodes. Correct? Anode is oxidation electrode and cathode is reduction electrode, and they are constructed by taking metal in metal ion solutions. Am I right? Okay, so I've told electrodes are not alone constructed just by dipping metal rods in their own metal ion solutions, but they are also constructed taking differently. How? Like the gas ion electrode, in which I'll pump in gas at hydrogen gas at 1 atmosphere pressure into a solution containing 1 m concentration of H plus ions. That's how that electrode is constructed. Okay, there's one more electrode called the calomel electrode, which is constructed by taking a metal dipped in or placed in a metal ion solution which is insoluble in it. Okay, there are also other electrodes like twin hadron electrode, which is an example of a redox electrode, and the last one is ion selective electrode. Okay, you understand? So roll number 70. Roll number
Yes,
70 is absent.
Present, ma'am.
Good morning.
Good morning, ma'am.
Harshita, Cheppunana. So what did you understand? How electrodes can be constructed?
Electrodes can be constructed by dipping rods
Ah.
in its
అదొకటేనా? అదొకటేనా? ఓ మెటల్ రాడ్ ని మెటల్ అయాన్ సొల్యూషన్ తో డిప్ చేస్తే సరిపోతుందా? ఇంకా ఎలా చేయొచ్చు?
connect it with wires.
సరే నాన్న, you understand my question? Why we are connecting them with wires? For the
Charges, flow of
flow
electrons.
Electrons. Good. For ionic equilibrium, what I'm going to do? To maintain ionic equilibrium, what I'll do?
Salt
I'll
bridge.
place a salt bridge. I'll place a salt bridge. Okay. Harshita, you haven't any idea after the discussion that how electrodes can be constructed. And electrode construction ki ఏం కావాలి? ఐడియా ఉందా లేదా? సరే, anyone in the class?
We need a metal.
Ions and atoms.
ఏంటన్నా?
A metal which can conduct electricity. We need a metal which can.
హైడ్రోజన్ గ్యాస్ ఇస్ ద ఎలక్ట్రోడ్ కదా, గ్యాస్ ఎలక్ట్రోడ్ లో హైడ్రోజన్ గ్యాస్ ని నువ్వు పంప్ చేసావు. హైడ్రోజన్ గ్యాస్ అట్ 1 atmosphere ప్రెషర్ you have pumped. Get back. How? So can I say that a metal at two different metal or non-metal at two different concentrations, if it is in contact, can form an electrode? That exactly what it is. If a metal or a non-metal is having an equilibrium at two different oxidation states, so whenever I am saying that, that forms an electrode. అర్థమైందా? అంటే ఏంటి, జింక్ రాడ్ ని జింక్ సల్ఫేట్ సొల్యూషన్స్. అక్కడ కాన్సెప్ట్ ఏంటి, ఒక జింక్, ఇప్పుడు జింక్ Zn+2 అంటే +2 ఆక్సిడేషన్ స్టేట్. అది దేంతో ఈక్విలిబ్రియం లో ఉంది, Zn0 అంటే మెటల్ రాడ్ మెటల్ అయాన్ సొల్యూషన్, అంటే సేమ్ స్పీషీస్ ఇన్ 2 different కాన్సన్ట్రేషన్స్. అలానే కాపర్ రాడ్ కాపర్ సల్ఫేట్ సొల్యూషన్, అది మెటల్ అయాన్ ఎలక్ట్రోడ్స్. గ్యాస్ ఎలక్ట్రోడ్ ని తీసుకున్నాం, హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్. ఏం చేసావు, ఎలక్ట్రికల్ కనెక్టివిటీకి ప్లాటినం వైర్ ప్లేస్ చేసావు, బానే ఉంది. దేంట్లో ప్లేస్ చేసావు, HCl సొల్యూషన్ లో. సరే, HCl సొల్యూషన్ లో ఏం అయాన్స్ ఉన్నాయి, H+ అయాన్స్ ఉన్నాయి. దాంట్లోకి నువ్వు హైడ్రోజన్ గ్యాస్ 1 atmosphere ఉన్నది పాస్ చేసావు. సరే, సో ఇక్కడ hydrogen gas, the equilibrium is between H in 0 oxidation state and H in +1 oxidation state. Ante 2 different oxidation states of the same species. Okay, so the discussion about the further electrodes. Ante iron +2 +3, they are in 2 different oxidation states. Okay, and these 2 species are in contact and they are in equilibrium, will form an electrode called as a redox electrode. Means you need to have same species in 2 different oxidation state for the construction of an electrode. Is the point clear? Okay, and thanks Ajay, you actually started the class in a very lively note. Okay, what I want to tell you is, get the concept, you can play with it. And you know, there's one common saying, in spite of having lack of time, still I can't say that I'll be very reluctant to be on a lighter note to you all. A class is a class, no matter how much pressure we have. You know what they say, all the songs or most of the songs, in fact most of the duet songs which you'd all like to listen, are for 15+. You're only, or mostly all of your age group people are those who fall under the category of singing. So we would like to say, just sing the song. Okay, but 50+ are the ones actually who write all these exemplary duets and all. 50+ people, they are really old people. You'd be surprised, they'd be writing all these things very confidently and efficiently. So singing is for 15+ and writing is for 50+. Okay, that's a idea. Why? Because 50+ people don't, most of the people don't remember the lyrics as much as you can. Okay, so they are efficient creating new lines and they'll somehow manage, but you can remember at your age. So please do remember the subject, that's the most important thing. Okay, keep to memorizing things. Okay, give a small browse to the last topic what we have discussed in any subject, that's a learning skill. Give a browse to the earlier class, whatever being taught, because it will be a continuous discussion happening. Okay, అంటే ఏంటి, సార్ క్లాస్ లో జాయిన్ అయ్యాక గబగబా ఒకసారి లాస్ట్ క్లాస్ రివిజన్ చేసిన వెంటనే యూల్ క్యాచ్ అప్. లేదా ఇంగ్లీష్ క్లాస్ మ్యాథ్స్ క్లాస్ అయిన వెంటనే ఫటామన్ కెమిస్ట్రీ క్వశ్చన్ అడిగితే కష్టం, అది కామన్ ఫర్ ఎనీవన్, బట్ హౌ టు క్యాచ్, దట్స్ ద వే. Okay, then that's it. So I hope all of you have understood that for oka electrode ni construct cheyalante same species 2 different oxidation states lo undali. Ante enti, Zn in contact with Zn+2 or H+ ante hydrogen gas pumped into H plus ion solution, or two oxidation states of iron, iron plus 2 and iron plus 3. Okay, అంటే ఒక సేమ్ స్పీషీస్ డిఫరెంట్ ఆక్సిడేషన్ స్టేట్స్ లో ఉండడం వలన ఆ రెండిటి మధ్య ఉన్న పొటెన్షియల్ డిఫరెన్స్ ని ఏమంటాను నేను? సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్ అంట. అది ఈ కింద రిప్రజెంట్ చేస్తాను. అది స్టాండర్డ్ కండిషన్స్ లో ఉంటే ఇట్స్ కాల్డ్ యాజ్ స్టాండర్డ్ ఎలక్ట్రోడ్ పొటెన్షియల్. దట్స్ వాట్ యూ నీడ్ టు అండర్స్టాండ్ వెరీ క్లియర్. Okay, now let's quickly go ahead discussing about the three electrodes which you have in your syllabus. Just now, I hope by this time you're clear with the metal ion electrode, the gas ion electrode, that is hydrogen gas electrode, in which I have constructed the EMF series taking standard hydrogen gas electrode. Okay, in that standard hydrogen gas electrode, platinum wire acts as an inert electrode. It just facilitates the absorption of hydrogen gas and flow of electrons. Otherwise, it remains neutral all throughout the process. Okay, the next one is metal insoluble salt electrode, that is calomel electrode. Okay, just kids, keep writing along with me. What electrodes you have in your syllabus for a discussion are the first one, the calomel electrode. The calomel electrode. What did I give you with respect to calomel electrode? It is metal insoluble salt electrode. Metal insoluble salt electrode. It's a very commonly used secondary reference electrode. Write along with me. Hope the board is clear. Commonly used secondary reference electrode. Okay. Very commonly used secondary reference electrode. Okay. Also, third one is, I'll straight away go with the construction of this electrode. Now, how it is being constructed. Hope you might have already known this. Okay. The electrode is built by taking a thick, strong glass tube, okay, which has two openings. Okay. One opening is for pouring KCl solution. The other opening is for salt bridge. Okay. Now this tube has actually a, what's the physical state of mercury? What is the physical state of
Liquid.
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 liquid? Correct. That pure liquid mercury, which is perfectly white in color, is placed at the bottom of the glass tube. On that, I'll place a paste of mercury and mercurous chloride. Okay, this is a paste of mercury and mercurous chloride, Hg2Cl2, which is a solid taken as a paste. Okay, and on that, the KCl solution is poured in. Okay, KCl solution. So it is an aqueous one. So aqueous KCl solution is poured on that. For electrical connectivity, I'll take a wire. Okay, which is fitted into a glass bulb, a thin long glass structure in which I have a wire, platinum, or sometimes any inert one I'll take for electrical connectivity. And that's the construction of the calomel electrode. Okay, so what calomel electrode is made up of? Okay, a calomel electrode is made up of mercurous chloride, okay, commercially called as calomel, KCl solution, and a platinum wire for electrical connectivity. That's a construction of a calomel electrode. ఏం చెప్తున్నా, ఎలక్ట్రోడ్స్ కన్స్ట్రక్షన్ అనుకుంటున్నాం. ఎలక్ట్రోడ్స్ కన్స్ట్రక్షన్ లో మెటల్ అయాన్ ఎలక్ట్రోడ్ చూసాము, గ్యాస్ అయాన్ ఎలక్ట్రోడ్స్ చూసాం. సరే, ఇప్పుడు నెక్స్ట్ డే ఏం చెప్పాను కన్స్ట్రక్షన్ లో? మెటల్ ఇన్సాల్యుబుల్ సాల్ట్ ఎలక్ట్రోడ్ చెప్పానా లేదా? థర్డ్ వన్ లో మొన్న రాసుకున్నారు. ఓకే, దాని బెస్ట్ ఎగ్జాంపుల్ ఏంటంటే calomel ఎలక్ట్రోడ్. ఎందుకు ఆ పేరు అంటే అది కమర్షియల్ నేమ్. Hg2Cl2 మెర్క్యూరస్ క్లోరైడ్ ని కమర్షియల్ గా calomel అంటారు, అందుకనే calomel ఎలక్ట్రోడ్ అని చెప్పి అడ్రస్ చేస్తున్నాం. ఓకే, సో ఈ ఎలక్ట్రోడ్ ఏంటి? వెరీ వెరీ కామన్లీ యూస్డ్ సెకండరీ రిఫరెన్స్ ఎలక్ట్రోడ్. ఓకే, దాని కన్స్ట్రక్షన్ ఏంటి? గ్లాస్ ట్యూబ్ ఉంటుంది, ఆ గ్లాస్ ట్యూబ్ లో థిక్ గ్లాస్ ట్యూబ్, దాంట్లో ఎట్ ద బాటమ్ మెర్క్యూరీ తీసుకున్నాను, దానిపైన ఒక పేస్ట్ ప్లేస్ చేశారు, మెర్క్యూరస్ క్లోరైడ్ పేస్ట్. Hg2Cl2 అంటే మెర్క్యూరస్ క్లోరైడ్, కమర్షియల్లీ దానిని calomel అంటారు. దానిపైన KCl సొల్యూషన్ యాడ్ చేశారు. ఓకే, KCl సొల్యూషన్ ఎలా ప్రిపేర్ చేస్తాం? వాటర్ లో KCl యాడ్ చేసి ఆ సొల్యూషన్ ని ప్రిపేర్ చేస్తాం. సరే, ఎలక్ట్రికల్ కనెక్టివిటీ కోసం నేను ప్లాటినం వైర్ ని ప్లేస్ చేస్తాను. ఓకే, ఈ ట్యూబ్ కి ఒక సైడ్ KCl వేయడానికి ఒక ఇన్లెట్ ఉంటుంది, ఇంకో సైడ్ సాల్ట్ బ్రిడ్జ్ ప్లేస్ చేయడానికి 2 ఆర్మ్స్ ని అరేంజ్ చేస్తాం. అది కన్స్ట్రక్షన్ ఆఫ్ ద calomel electrode. So I'll give the notes to you, but this is for the explanation. Okay, fine. Now what else can I write here? What might be the fourth point? Now can you write the cell notation or cell representation? Can you all write the cell notation or cell representation? By the way, let me ask you a question. What it means by a reference electrode? Roll number 100. What it means by a reference electrode? Roll number 100 is present. Good morning. Roll number 100 is absent. Okay. Roll number 110. Good morning.
Good morning.
Yeah. What it means by a reference electrode, Varun? వచ్చావా మొన్న సాటర్డే క్లాస్ కి?
Stable electrode potential.
స్టేబుల్ ఎలక్ట్రోడ్ పొటెన్షియల్ అంటే ఏమిటి? ఈఎంఎఫ్ కాన్స్టెంట్ ఉంటుందా, వేరీ అవుతుందా?
Constant ఉన్నది.
సో రిఫరెన్స్ ఎలక్ట్రోడ్స్ అంటే ఏంటి? ఎలక్ట్రోడ్స్ దగ్గర అయితే ఈఎంఎఫ్ కాన్స్టెంట్ ఉంటుందో, అవి జనరల్ గా ఏవైతే మనము స్టాండర్డ్ కండిషన్స్ లో ఉంచుతామో అలాంటి ఎలక్ట్రోడ్స్ ఏమంటాను? రిఫరెన్స్ ఎలక్ట్రోడ్స్. చెప్పు నాన్న. ఇప్పుడు ప్రైమరీ రిఫరెన్స్ ఎలక్ట్రోడ్ ఏంటి?
Primary reference electrode SC or NH.
దాని ఫుల్ ఫామ్ ఏంటి?
Standard hydrogen
గ్యాస్ ఎలక్ట్రోడ్. స్టాండర్డ్ హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ ప్రైమరీ రిఫరెన్స్ ఎలక్ట్రోడ్. ఓకే, కానీ ఆ ఎలక్ట్రోడ్ ని ల్యాబ్ కండిషన్స్ లో వాడలేము. ఎందుకు? హైడ్రోజన్ గ్యాస్ ని 1 atmosphere ప్రెషర్ దగ్గర పంప్ చేయడం అనేది హెర్క్యూలియన్ టాస్క్. ఇంకోటి ప్యూరిటీ ఆఫ్ ద గ్యాస్ ని మెయింటైన్ చేయాలి. అందుకని నేను ఏం చేస్తానంటే అలా హైడ్రోజన్ గ్యాస్ ఎలక్ట్రోడ్ లాగా ఏ ఎలక్ట్రోడ్ అయితే బోత్ యానోడ్ కింద క్యాథోడ్ కింద యాక్ట్ చేసి స్టాండర్డ్ కండిషన్స్ లో ఉండగలదో వాటిని రిఫరెన్స్ ఎలక్ట్రోడ్స్ కింద తీసుకున్నా. అలాంటి వన్ ఆఫ్ ద రిఫరెన్స్ ఎలక్ట్రోడ్ ఏంటి? క్యాలమల్ ఎలక్ట్రోడ్. ఓకే, అలాంటి ఎలక్ట్రోడ్స్ కి ఈ నాట్ వాల్యూ 0 ఉండదు, ఎంతో కొంత ఉంటుంది, బట్ ఇట్ రిమైన్స్ కాన్స్టెంట్ during the operation, and hence it is called as reference electrode. Is the point clear to all of you? Okay, so it is a secondary reference electrode. So its E value is there, it's not 0, but it is commonly used for laboratory purposes. How it will act as, when you'll say it is a reference electrode, if its EMF is remaining constant during the operation, okay, and also it can act as both anode and cathode, then in such conditions you'll say that the electrode is a reference electrode. Okay, so good, Varun. Now roll number 120. Good morning.
Yes, ma'am. Good morning, ma'am.
Okay, yeah చెప్పు నాన్న. సెల్ నొటేషన్ లో బై స్టాండర్డ్ డిఫాల్ట్ ఏది రాస్తావు? ఆక్సిడేషన్ రాస్తావా, రిడక్షన్ రాస్తావా? ఎప్పుడన్నా బై డిఫాల్ట్ ఎప్పుడన్నా సరే నువ్వు ఈ చాప్టర్ లో ఏ వాల్యూస్ రాస్తావు? ఆక్సిడేషన్ పొటెన్షియల్స్ రాస్తావా, రిడక్షన్ పొటెన్షియల్స్ రాస్తావా?
Reduction potentials, ma'am.
రిడక్షన్ పొటెన్షియల్స్ రాస్తావు. సో బై డిఫాల్ట్ దీని సెల్ నొటేషన్ రాయాలి అంటే ఏం రాయాలి నువ్వు? ఆక్సిడేషనా, రిడక్షనా?
Reduction, ma'am.
Good, reduction. Okay, so reduction ante it will act as anode or cathode. Reduction takes place at anode or cathode?
Cathode, ma'am.
Cathode. So what is the reduction reaction? What is the reduction reaction? So first it should be ionic in nature. Hg2Cl2, it is solid. This is the oxidized form. Okay, it will form Hg liquid, comma KCl. Okay, aqueous, concentration C1. Okay, and platinum wire for electrical connectivity. That is the cell notation of the calomel electrode. Is it clear? Does anyone has a doubt?
Ma'am,
Okay.
can calomel can be used as a reference electrode in halide solutions, ma'am? Halide solutions.
Point ఏంటి? రవీందర్
Yes, ma'am.
అది ఇప్పుడు నువ్వు just hold on, my discussion is incomplete. Hold on, my discussion is incomplete. You get to know it after the conclusion of the topic. After the conclusion of the topic.
Okay, ma'am.
Okay, just listen to me. But did every one of you understand why the cell notation is? Okay, Hg2Cl2 solid, Hg liquid, KCl aqueous, and its concentration is important. So I've kept it as C1 and platinum. Why I have not written concentration with the H plus ion is because it is a solid and its concentration is taken as 1 for any metals. Okay, or metal ions in the solid state, the concentration is always equal to 1. Is the point clear? Okay, so it's a cell notation. Hope you are writing all with me. Okay, the notes are given, these are very important for you. That is the cell notation. Okay, next point, point number 5. Point number 5 under calomel electrode, we'll write electrode potential of calomel electrode depends upon electrode potential of calomel electrode depends upon the concentration of KCl solution. Okay, depends upon the concentration of KCl solution. Therefore, what do you say? Right in this block, calomel electrode is reversible to Cl minus ions. Calomel electrode is reversible to Cl minus ions. I hope you're jotting down the things along with me. Okay, now point number 6. Depending on the concentration of KCl solution, calomel electrodes are of 3 types. Calomel electrode, which are represented as Ce, is of 3 types. Okay. Saturated calomel electrode, saturated calomel electrode, saturated calomel electrode. Okay, whose E value is E, only E, 0.2422 volts. Then here the KCl solution is saturated. Here the KCl solution is saturated. The second one is normal calomel electrode. It is represented by SCE. Saturated calomel electrode is represented by SCE. Then you have the other one, normal calomel electrode, represented by NCE. Here KCl solution is 1 normal or 1 molar or normal. Its E naught value is equal to 0.28 volts. Its E naught value is 0.28 volts. The other one is decinormal calomel electrode. Decinormal calomel electrode represented by DNCE. Here the KCl solution is decinormal or N by 10. Concentration. Its E value is 0.334, around 4 volts. 0.334 volts. Okay, that's about the 3 different types of calomel electrodes. Okay, hope you understood. It's an easier one. Okay. Now I have a question to the entire class. Which is a standard calomel electrode? Out of these 3, which is a standard calomel electrode? I feel, are you taking a nap? Busy writing? Huh? I've told you I
No,
might
no, ma'am. We are listening.
NCE ma'am.
NCE na ఎందుకు
1 molar is the concentration ma'am. Standard concentration.
E
కరెక్ట్
not value.
ఈ నాట్ అంటే ఏంటి ఎప్పుడు ఈ నాట్ వాల్యూ తీసుకుంటా at 25 degrees centigrade and temperature and concentration of the electrolyte should be 1 molar or 1 normal. Okay, so E naught value is 0.28 volt. Okay, so normal calomel electrode is always taken as the standard calomel electrode, but in lab we always use a saturated calomel electrode. And why it is a reference electrode? Suppose nu dani titrations ki vaartunnav anko, okay, experiment you will do the experiments with this electrode. Okay, ఆ ఎక్స్పెరిమెంట్ చేసినంత సేపు ఆ ఎలక్ట్రోడ్ దగ్గర calomel electrode దగ్గర always the EMF remains constant at 0.2422 volts. Okay, because the EMF is remaining constant, that electrode is called as reference electrode. So what are reference electrodes? Reference electrodes are those electrodes at which EMF remains constant during the operating conditions. Okay, it becomes standard when the normality is 1n. Okay, here in this case, in the calomel electrode which is saturated, it is not a standard calomel electrode, it is just saturated calomel electrode. Hope you understand. It's not under standard conditions, but still it is used as a reference electrode because its EMF is remaining constant at 0.2422 volts wherever it is being used. Okay, and which electrodes will act as reference electrodes? Okay, its EMF should remain constant and it can act as both anode and cathode. Okay, so the next one is 7th one. 7 point. So calomel electrode can act as both anode and cathode. Okay, so what's the 7 point? If case 1, that's better. Point number 7, case 1, if calomel electrode is cathode. Calomel electrode is cathode. Then what reaction takes place? Oxidation or reduction? Is the board clear? If calomel electrode is cathode, what's the reaction happening? Oxidation or reduction? ఇంత మెల్లిగా చెప్పింది ఎందుకంటే మీరేవో ఇవన్నీ చెప్తారని. At cathode, oxidation or reduction?
Reduction.
Can you write now the reaction? Come on, you should know. It's not a big deal for you. It's not a rocket technology out there. You can't do it. So already we have already given what's a reduction reaction. For a reduction reaction, I should take Hg2Cl2. It is called as mercurous chloride. Okay, black color, commercially called as calomel or calomel, commercial name. Okay, Hg2Cl2. Okay, what's the oxidation state of mercury? Cl is minus. So what's the oxidation state of mercury? Hg plus. It's a dimer actually. Takes 2 electrons. Double arrow. It is solid or liquid? It's a solid. Okay, it will form Hg liquid. Okay, plus 2Cl minus, that is aqueous. Fine. Whatever I've written on the board is clear, understood? Okay, is it a reduction reaction? Correct. It's a reduction reaction. Okay. So, what will happen to the concentration of Cl minus ions in reduction? Increases or decreases? Come on, answer my question quickly. What happens to the concentration of Cl minus ions if calomel electrode is acting as cathode? మీరు ఇలా
ఇంక్రీజ్
ఇంక్రీజింగ్
డిక్రీజెస్ రిడక్షన్
ఏమవుతుంది? ఓకే, చెప్పాలి.
రిడక్షన్ గెయిన్ ఆఫ్ ఎలక్ట్రాన్.
రిడక్షన్ గెయిన్ ఆఫ్ ఎలక్ట్రాన్స్. సో ఎలక్ట్రాన్స్ ఏది గెయిన్ చేస్తుంది? అయోనా మెటలా? అయోనా మెటలా? మెటలా? మామూలు క్లాస్ అంటే మీ అందరినీ ఒక రేంజ్ లో చేసేదాన్ని, పాత పెట్టేసేదాన్ని. ఇది ఇంకోలా రాయచ్చా? Hg plus electron gives Hg plus Cl minus. In the equation, right or wrong?
రైట్ మ్యామ్.
రాంగ్. ఎందుకు? రైట్ అయితే ఎందుకు? ఇది మీరు చిన్న చిన్నవి నేర్చుకోవాలి, మీరు చేయగలరు. మీరు యూ ఆల్రెడీ డన్ దిస్ ఇస్ వాట్ ఈస్ సర్ప్రైజింగ్. అటెండెన్స్ తీసుకుంటే టక అందరూ వచ్చేస్తారు. వాట్ రెహమాన్ 88, గుడ్ మార్నింగ్.
No, ma'am, I was outside, ma'am. Just 5 minutes before I left the meeting. Just 5 minutes before I left the meeting, ma'am.
Is the equation right or wrong?
Where did Cl came from, ma'am?
Correct. The equation is correct. Perfectly correct. Okay. But because it's a dimer, it will be 2Hg plus. Okay. So 2 electrons, 2Hg, 2 Cl minus. That's the only thing. Okay. Now can you apply Nernst equation here? Please apply Nernst equation and write. Applying Nernst equation. Applying Nernst equation, we have E calomel electrode is equal to E naught calomel electrode minus 0.0591 by 2 log concentration of products by concentration of reactants. Okay, that's the Nernst equation. I can summarize this as this and this gets cancelled because it is pure metal, zero oxidation state, and here the concentration of the solids is taken as 1 always, since concentration of Hg and is equal to concentration of Hg2Cl2, which is equal to 1. The equation becomes E calomel electrode is equal to E naught calomel electrode minus 0.0591 by 2. This 2 also will go. It goes to log concentration of Cl minus ions, or you can write like this. Is the equation correct?
Yes.
Right or wrong?
Right.
Right. Okay. So what your logic says? What will happen to the concentration of Cl minus ions during the reduction process? Reduction అవుతుంది అనుకో, ఏది రెడ్యూస్ అవుతుంది? మెటల్ రెడ్యూస్ అవుతుంది, మెటల్ అయాన్ రెడ్యూస్ అవుతుంది. So Hg plus is taking electrons, okay, and it is releasing Cl minus ions. Itself is getting converted to mercury. So what happens to the concentration of Cl minus ions? It increases when it is acting as cathode and undergoing reduction. After writing everything, what I've come to the point that here the concentration of Cl minus is what is very important. Okay, so that's the first one. What will be case 2? Case 2 is if calomel acts as anode, then the reaction is oxidation. Okay, that is loss of electrons. Now, which will lose electrons? The mercury metal. Mercury metal, okay, loses electrons in the presence of KCl, aqueous, okay, will lose electrons to form H3 2Cl2, which is a solid. Okay, fine. Plus 2 electrons. Is the equation correct?
No, ma'am.
No, na. ఎందుకు నాన్న?
Potassium. In products,
నేను
potassium not there, ma'am.
ఎందుకు సోమేశ్వర్ ఏం చెప్పు?
బ్యాలెన్స్ కాలేదు మేడం ఈక్వేషన్ అంటే.
బ్యాలెన్స్ అవ్వలేదా?
పొటాషియం ప్రొడక్ట్స్ లేదు.
K ప్లస్ ఓకే, K ప్లస్ నేను ఇగ్నోర్ చేశా. సొల్యూషన్ లో ఉంటుంది, aqueous సొల్యూషన్ లో. అదర్వైజ్ ఇట్ ఇస్ కరెక్ట్?
yes
yes. అంటే యాక్చువల్లీ ఇది ఎలా రాయొచ్చు అంటే 2Hg gives 2Hg plus 2 electrons. Okay, these 2Hg plus will take Cl minus 2 Cl minus ions from the KCl solution to form Hg2Cl2. This is how it is written actually elaborately, but this is the right representation. Okay. Now what will happen to the concentration of Cl minus ions? It will decrease when it is acting as anode. Now I'll again apply Nernst equation. Apply Nernst equation. Applying Nernst equation, we have E calomel electrode is equal to E naught calomel electrode minus 0.0591 by 2 log concentration of products to concentration of reactants. Okay, this equation can be further written as E naught calomel electrode minus 0.0591 by 2 log, this and this gets cancelled, this becomes plus Cl minus taken square. Okay, correct? Fine. Fine. Now I'll write I can write. Did you all take this down? So what's going to be the 8th point? If calomel electrode, is anode, concentration of Cl minus ions decreases. If calomel electrode is cathode, concentration of Cl minus ions increases. Therefore, calomel electrode is reversible to concentration of Cl minus ions.
Ma'am, adjust the camera, ma'am.
Okay, I'll write it to the top. Can you see till this point? Okay, so I'll write it to the top. Therefore, calomel electrode is reversible to Cl minus ions. That's the conclusion. Fine. Roll number 111. Good morning. Is he present? 111. Absent. Okay. 101.
Yes, ma'am.
Yeah. Did you understand with the concept?
Yes, ma'am.
Okay. Is Hg2Cl2 soluble in KCl or Hg? అర్థమైందా నాన్న నా క్వశ్చన్? శ్రీష్మా,
No, ma'am.
ఇప్పుడు Hg2Cl2 సాల్ట్ కదా, మెర్క్యూరస్ క్లోరైడ్ సాల్ట్, అది బ్లాక్ కలర్ లో ఉంటుంది. కమర్షియల్ నేమ్ ఇస్ calomel. What's your idea? Is it soluble in KCl or Hg? Any of these two liquids?
Yes, ma'am.
Yes, sir. ఆలోచించి శ్రీష్మా. Yes, sir. Calomel electrode construction లో ఏం చెప్పాను? Anyone from the class? It is first the H silver, on which there is silver
Insoluble
chloride
in
base.
salts.
Insoluble. Okay, దాని మీద KCl solution వేసాను, aqueous. Okay, so this is an example of metal insoluble salt electrode. అర్థమైందా? అంటే మెటల్ ఏంటి ఇక్కడ? Hg. మెటల్ ఇన్సాల్యుబుల్ సాల్ట్ ఏంటి? Hg2Cl2. Both are insoluble and hence is an example of metal insoluble salt electrode. Okay, and why it is acting as reference electrode? Because it can act as both anode and cathode due to the presence of KCl solution which supply KCl. Okay, and it is reversible to Cl minus ion. The next heading is twin hydron electrode. quinhydrone electrode. Quinhydrone electrode. Did I give this example anytime? Did I ever tell about quinhydrone electrode?
Yes, ma'am. Redox electrode.
Yes, it's an example of a redox electrode. So what is the first point? What's the first point? Quinhydrone electrode. It's a redox electrode. It's a redox electrode. It is working or indicator electrode. Working or indicator electrode. It is working or indicator electrode. Okay. Next point is construction. What is the construction? It is a black powder containing, it is a black powder containing equimolar proportions, that is 1:1 of quinol and quinone. Equimolar proportions of quinol and quinone. Okay. Benzene. Benzene, okay, 0 to show that it has resonance. Okay. Benzene with one OH group is called. Benzene with one OH group is called.
Alcohol.
Phenol.
Phenol. It's an alcohol, but it's called phenol. Okay. And one more OH at para position is called. One more OH at para position. Ante ఈ OH group ki idemo ortho, idi meta, idi para, ante opposite. 1/4 position is called as quinol. And or hydroxyquinone. Quinol represented by QH2 or hydroxyquinone. Okay, or it is also called hydroxyquinone. Okay. Now take away these two hydrogens, then it is oxidation or reduction. If I remove hydrogens,
Oxidation.
it is oxidation. If I add oxygen, it is called as oxidation. If I remove hydrogen, it is called oxidation. Okay. If I add hydrogen, it is called as reduction. Okay. What I have done, I have removed the hydrogens. Okay. So it is also again oxidation. So this oxidized form of this quinol is quinone. and is written like this. This is phenol, which is the oxidized form of phenol and is represented by Q. Okay, it's not resonated. This is the structure. Okay, fine. I think 5 more minutes is there. But strength very potent. I don't like kids who join now. It's very bad practice. Be sincere. Leave the session by chance if you're not there in the class. You're not good because you're I am authoritative or you're smart. It's a stupid smartness you're expressing. Those who have joined now, please leave. That's it. One word I can say. If I realize something else, then your nicety and my nicety are these are lost. Did you take it down? Okay. Have a question. Which is the right way to write? Don't write this. It's a question. Which is the right representation? Which structure is correct? Structure 1, structure 2, and structure 3. Which is correct? Okay, just answer the question. By chance you know it and you need to stop it. This you have all studied in your intermediate or +2, +1, +2. Probably even in 10th class. Date is 7th. You would answer Chapara.
Second
One,
one.
All.
1 and 2, ma'am.
Second one.
Second.
61.
Yes, ma'am. All are
62.
correct, ma'am.
Present, ma'am.
63.
Present, ma'am.
64.
Present, ma'am.
65.
Present, ma'am.
66.
Present, ma'am.
67. 68.
Ma'am, 67 present, ma'am.
69.
Present, ma'am.
67 present, ma'am.
70. Correct.
70 present.
70. 71.
Present, ma'am.
72.
Present, ma'am.
73.
Yes, madam.
74.
Present, madam.
75.
Present, ma'am.
76.
Present, ma'am.
77.
Present, ma'am.
78.
Present, ma'am.
79.
Present, ma'am.
80.
Present, ma'am.
81.
Yes, ma'am.
82.
Present, ma'am.
83.
Present, ma'am.
84.
Present, ma'am.
85.
Present, ma'am.
86 is absent. 87.
86 present, ma'am.
Present, ma'am.
88.
Ma'am, 86
Present,
present, ma'am.
Correct.
88 present.
88.
Present, ma'am.
89. 90.
Yes,
91.
ma'am.
No, 90. 91.
Present, ma'am.
92.
Present, ma'am.
90.
93.
Present, ma'am.
Yes, ma'am.
94. 95, 96, 97, 98, 99, 100, 1,
Present, ma'am.
2,
Present, ma'am.
3,
Present, ma'am.
4,
Present, ma'am.
5, 6, 7, 8, 9,
Present, ma'am.
10,
Present, ma'am.
11,
Present, ma'am.
12,
Present, ma'am.
13, 14, 15, 16,
Yes, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Yes, ma'am.
20.
Present, ma'am.
First two are correct. The last one is wrong. I want to show that the electrons are in resonance. So either I'll put a knot at the center, okay, to show that the electrons are resonating, or I'll put alternate double and single bonds like this to show that the electrons are in resonance. This structure does not have show in what's this? You've shown the resonance and another one in the center. That means you're confused. So the third structure is wrong. These two are correct. Okay. And why I've explained this to you is to tell the structure of the quinone. Here it is saturated compound and the electrons are in resonance. Now what I have done, I have snatched away the electrons. Okay. So because of that, there is resonance disturbed. So I've represented Q like this. Okay. And tomorrow we'll just conclude this electrode and start with the glass electrode. Good day.